Why does gravity matter? Exploring its role in space and time? We couldn't live without gravity. Without it, we'd drift away into outer space. But gravity does a lot more than that. It shapes the very structure of our universe. In fact, you could say that gravity is the sculptor of space and time, and in this sculpture, everything has changed. Welcome to my channel. All the planets in our solar system orbit the sun in perfect elliptical paths, never crashing into each other or the sun. But let's imagine what would happen if Earth suddenly had no gravity. Without the force that pulls us down to the ground, we'd float away from the planet and eventually get sucked into the sun. That seems pretty dramatic, doesn't it? Well, not nearly as dramatic as what would happen if the sun, one of our closest neighboring stars, went missing. You see, massive stars like the sun have an incredible amount of gravity. In fact, all the planets in the solar system, including Earth, are held in their orbits by the sun's gravitational pull. If the sun were to disappear, Earth would continue moving forward in a straight line, which means it would eventually crash into the planets that orbit closer to the sun, like Mercury, Venus, and Earth. In fact, Earth would pass through the asteroid belt and comet belt and eventually be flung out of the solar system entirely. So if you want to thank a star for keeping you grounded, literally, you know which one to thank. But what if we took this idea of grounding to the extreme? What if we created a situation where Earth had so much gravity that nothing could escape its pull, not even light? If that sounds impossible, you're right. It can't happen here because there's not enough mass around. But let's try something else. Let's change the shape of Earth. If we took Earth and squeezed it, making it smaller, the gravity would increase until it became so strong that it pulled everything, including light, toward its center. At this point, Earth would look like a gigantic ball of dense, dark matter. And because it would be so massive, other things would start to happen. First, the star closest to us, the sun, would start to orbit our superpowered Earth. Then all the other planets would be pulled out of their orbits and start crashing into Earth. Eventually, Earth would become the center of a new solar system with all the other planets orbiting around it. This is how gravity can change space. But what about time? Turns out that when you mess with gravity, you also mess with time. Remember that superpowered Earth? The intense gravity would actually slow time down. That's because near a massive object, time moves more slowly than far away from a massive object. Since Earth would be so massive, time near its surface would move much more slowly than it currently moves. And if you were standing on that superpowered Earth, you'd feel like you were living in slow motion. So remember, gravity isn't just a force that keeps us grounded. It's a sculptor that shapes our universe, a choreographer that dances with the planets, and a timekeeper that ticks to the rhythm of the cosmos. And if any of these concepts seem a little confusing, don't worry. Just remember, it's all relative. Have you ever wondered why a stone falls to the ground when you drop it, or why planets orbit around the sun? If you'd like to know more about this and other physics mysteries of the universe, subscribe for more videos. This is a super simple physics question, but it took me a long time to answer it because I didn't know what to look for. Turns out, it's a lot harder than you think to figure out why gravity matters. You see, if there were no gravity, nothing would stay on the ground. It'd be hard to walk, sure, but more importantly, we couldn't hold things still. Nothing would stay in place. But then again, if gravity were stronger, say, twice as strong, people would get hurt. Buildings would collapse. Planes would fall from the sky. So it turns out that the strength of gravity is really important. And this made me wonder, is there an ideal strength for gravity? You know, some strength that allows planes to fly and buildings to stand upright and people to walk without falling over. I mean, if everything is always pulled towards the center of the Earth by gravity, why don't we just adjust the strength of gravity so that everything is just barely held up? That way we could have all the benefits of living on a planet with solid ground. But we could also go swing and never fall down. It turns out that the reason why gravity needs to be just right has to do with the nature of space and time. Here's what I mean. Imagine you're standing on a very tall building and you throw a ball straight up in the air. The ball goes up and then it comes back down. Easy peasy. Now imagine that you do the exact same thing, except you throw the ball when you re-on a rocket ship that's blasting straight up through space. Like in the beginning of the movie WALL-E. In this case, the ball goes up and it doesn't come back down. It just keeps going up forever. So why does the ball fall back down when you throw it on Earth, but not when you throw it on a rocket ship? Well, it has to do with the curvature of space-time. Space-time tells us how much things will fall, or how much time will pass based on where they are relative to other things with mass. The more massive an object is, the more it warps space-time around it. And the further away you are from an object, the weaker its gravitational pull is on you. When you throw a ball on Earth, it goes up and then comes back down, because the Earth's gravity pulls it back down. But when you throw a ball on a rocket ship that's moving away from the Earth, the ball doesn't come back down because the rocket ship is moving away from the part of space-time that's being warped by the Earth. So here's the amazing thing. When you're on Earth, space-time is curved in such a way that things fall towards the center of the Earth at just the right rate. If gravity were any weaker, people and buildings and planes would fall over. And if gravity were any stronger, people and buildings and planes would be crushed. So the fact that you can walk and talk and drive without falling over or getting crushed means that the space-time around Earth is curved just right. If you want to learn more about the space-time, check out the brilliant course on general relativity. Thanks for watching.